Today we will discuss about the last topic of this module 4. That is Hadoop archives and load balancing, cluster load balancing. These two are quite few research topics. So if you want to do some project on big data analytics, this is a very good area where you can certainly work on it, right? So coming on to the concept, keeping an HDFS cluster balanced. So this is a concept where how do you keep your cluster always balanced? See, if there are cases where clusters going to fail, the reason is it is not balanced. So sometimes maintaining the balance is one of the very good administrative concept of any Hadoop cluster, right? And Hadoop certainly employs this in the name node itself. So when you are copying data into Hadoop distributed file system, so it is important to consider the cluster balance. And if a Hadoop distributed file system works best when the file blocks are evenly spread. So very important. So Hadoop will perform extremely well if the cluster is balanced well. If the cluster is not balanced well, definitely it won't perform, because most of the traffic will be given to a same node. So what happens? There will be a lot of bottleneck happens. Only one node serving, all other nodes are simply idle. So it happens many times, and if the load is spread across all the nodes of the cluster, so what happens? Data is spread across many data nodes, and simultaneously, parallelly, the reading, parallel writing can be easily done. Parallel analysis is also done easily. So it becomes very easy. And of course, that is one very important point that you should understand. And going back, suppose going back to 100 GB, 1000 GB example. So by specifying, so when you are copying disk copy 1000 GB of data, so what happens is parallelly you are copying. So when you are copying parallelly, of course, you have to maintain three replication copies. Yes, of course, they are maintaining it. And if you specify m is equal to 1 minus m as 1, m means the map. See, whatever it is, the data node and name node, they are actually the devices, storage devices, computers. The master computer, you call it as name node. The storage computers are called a data node. But actual working, who is doing? Actual work is done through a programming concept, a programming function called map function. Map is a function that is actually working. So if you specify map is equal to 1, what happens? Only one map function. That means only one program is running, taking all 1000 GB of data, and it is storing according to the instructions from name node. So only one person doing. One person doing 1000 GB data is definitely, it is a slow process. And of course, is not using the cluster resources efficiently. So what that map will do, wherever it is nearby, it will keep all the data in nearby. It is just like, so if you are asked to, normally during village sites, so ತೆಂಗಿನಕಾಯಿ ಸುಲಿಯೋದಕ್ಕೆ ಹೇಳ್ತಾರೆ, 1000 ತೆಂಗಿನಕಾಯಿ ಹಾಕ್ಬಿಟ್ಟು ಒಬ್ಬನ ಕೈಯಲ್ಲಿ ಸುಲಿಸಿದ್ರೆ ಏನ್ ಮಾಡ್ತಾರೆ? What he will do, he will keep all those waste and all those coconuts in nearby. So he'll not arrange properly. It's the same thing, and his process will be slow. If this process, if it is given to almost 100 people, so almost what happens, the process becomes much faster, and the work happens in parallel, and also they have to maintain replica of 3. So it is again big issue. So if it is not properly stored, what happens, properly balanced, what happens, it is very difficult for traffic to control, the request traffic, the modification traffic, the data that we need to work, analyze. Next chapter is about the data analysis. Data analysis using MapReduce, another very important chapter. It is the heart of the big data analytics. So map and reduce. So when you do MapReduce operation, if the data is not evenly distributed, so what happens? You will find a lot of problems. So that's the reason we have to maintain, a proper balance in the cluster. Of course, the second and third replica would be spread across the cluster, but this node would be unbalanced. So what happens, where the single map is running, there actually you will have a lot of data. Other blocks will have a less number of data. So it will create imbalance, and it will create a lot of problem with respect to what we call the reading and writing of data further later further. So if distributed copy, parallel copying, if it is having 20 maps, 20 maps means 20 workers. So what happens if 20 workers are there? So evenly distributed, these 20 workers are kept in different places. That means different data nodes. So what happens, easily the data can be easily distributed, evenly distributed, parallelly distributed, so that data can be balanced. However, it is not always possible to prevent a cluster from becoming unbalanced. Every time what happens, unbalance happens, and you have to apply some algorithm so that data should be balanced. So that's the thing. So balancer is a tool that is there in HDFS, which will take care of most of the balancing operations. It will be taking care. And in the balancer, there are 3 balancing algorithms running. One is round robin. So round robin, in the sense, it will keep the look at the previous diagram. Okay, round robin, first one. So what happens during round robin? So if this is load balancer is running, simple. So if a first request comes, so what happens? The first block will be kept in first track, and the second file block comes, it will be kept in second rack. If the third is it is kept in third rack. Again, fourth in the same first track, fifth in the same second rank, and sixth in third rack. So round robin, one by one. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So it is following the same thing. And finally, what happens? Data easily fits into this, into the balancing. So that is one algorithm that we have. So round robin algorithm. Second one, least connection. Least connection in the sense, there are clusters which there are computers, data nodes. You need to go till the end. So in the rack. So what you will do? You will think, so which is nearby, you will keep there. So nearby connection you will keep, so that your cost will be reduced. So least connection. Third one is IP hashing. IP hashing is nothing but so for a set of clients, okay, based on the IP address, what happens, you will apply some hashing algorithm. This hashing algorithm will automatically choose the data nodes, randomly. So this hashing algorithm based on the hashing function, what you write inside this hashing algorithm will decide where exactly this particular IP will be mapped onto this particular cluster. So a particular set of data nodes are mapped to particular IP. So only that IP will be storing, only particular IPs are storing data in these data nodes. So if you do like that, what happens? It becomes very easy for total management of Hadoop cluster. So that is load balancing algorithm. Of course, load balancing algorithms are not there for your syllabus. I just shared with you this load balancing algorithms. Further, uh, the next concept is Hadoop archives. Hadoop archives are nothing but the compression, how compression happens in Hadoop. So, very, very important thing is HDFS stores small files inefficiently. This is one of the statement I have been making from the beginning. So, if you store small files, small sized files in Hadoop clusters, so what happens? The storage becomes inefficient. Since each file stored in a block and block metadata is held in the memory by the name node. So even though you have 1 KB data, even though you have 1 MB data, so each block will be of 128 KB. So suppose if your data is 1 MB, so entire 128 MB block is allocated to your 1 MB. And what about the rest 127 MB? It is get wasted. So in the block is having capacity of 128 MB, and you are storing a small file of 1 MB, which is of very not efficient use. Of course, thus a large number of small files can eat up a lot of memory on the name node. And of course, note, however, the small files do not take up more space than the required to store the raw contents in the file. So even the file size is less, but it occupies more space. That is a concept here. For example, 1 MB file stored with the block size of 128 MB uses 1 MB data, not 128 MB. So 127 MB is left in the block as it is, getting wasted. So that is the problem. So what we will do, we'll use, the solution is, we'll use Hadoop archives. It means we compress all these data. Hadoop archives are HAR. In short, we call it as our file archiving facility that packs file into Hadoop blocks more efficiently, thereby reducing the name node memory usage while still allowing transparent access to files. Particularly, Hadoop archives can be used as to input to MapReduce. Of course, sometimes what happens, we have to store small files. In order to store small files, so what we'll do, we'll archive it. We'll we'll compress the files. So when we archive the files, what happens? These left blocks are being allocated for some other. So this archive is again another program that will make efficient usage of these blocks. So which will pack the files into a single block. Many files will be packed into single block and it will maintain. So that is what we call it as Hadoop archive. And how to do that archiving? The Hadoop archive is created from a collection of files using archiving tools And of course, the tool runs a map-reduce job to process. Of course, we'll discuss what is exactly a map-reduce job in the next next module. But remember, map and reduce are two program functions, so that parallelly work in clusters. So to run it, we need a MapReduce cluster running to use it. Here are some files in the HDFS that would like to be archived. So look at here. So I have just a LSR. LSR means list the files recursively. So in the folder, my files. Okay. If you do it, there are so many files are available. You can see so many files are available, and there is one directory is also available. So dir is one directory. In my files, you have one file A. In dir, you have one file B. So what you will do? These are all small files, and these small files I want to put it in an archive. So now we can run an archive command. How to archive the command? So command is Hadoop archive minus archive name. Name of the archive is files.har. Files.har. Har is Hadoop archive. It is the name of the zip file. What it will do? It will take all the contents from my files, and also it also takes contents from my. So it takes the contents from my files and also takes contents from my. And what it will do? It will archive. Okay, it will archive, same command. The first option is the name of the archive. That is archive file, that is files.har. Har files always have the extension .har, which is mandatory for the reason that we shall see later why. And of course, next comes the files to put in that archive. So we are having only one source tree, that is in the /my/files. So but the tool accepts multiple source trees, so you can write any number of file trees. So if you just write the folder name, automatically all the files that are there in the folder will be taken for archiving. And final argument is the output directory. Output directory, that is a HAR file. Yes. So where a HAR file has to be stored. Yes. So here, see, it will take all the files from this my files and it will be stored in my. So this is the directory where this files.har is going to store. So if you just give the list after this compression command, archive command, so you can see there is a file. So files.har. So this is the file that you are going to get. Files.har is the file that you are going to get. Now, once you got, now you see what is there inside this. Just type ls my files.har. So if you see what is there in these files, the files are not stored as the names. It will be having an index file. It will be having a master index file. So index file contains the name, actual names of the file, and master index is a backup. And part zero is nothing but it's one complete block. One complete block information, we call it as part zero. So how many files you can fit in within part zero is actually the size of 128 MB block. So small files, 2 MB, 3 MB, 5 MB, 10 MB, 20 MB, 40 MB, 6 KB, 100 KB, 20 MB, 30 MB, 80 MB, all those small files, everything it will store. It will be kept in part zero, because altogether part zero should contain maximum of 128 KB. So 128 MB. So what happens? So many files are kept in part zero. So this is how it is going to pack. So when it is packed as a single block and single file under a single file, so what happens? You create an efficient memory management, memory block usage management, concept. So that is the reason, archives are very much helpful. And of course, if you want to see what is there in particularly in those two index files, you can certainly, the part files contains the contents of the number of original files concatenated together, and the indexes makes it possible to look up to the part file that an archive file is contained in, and it is offset of the length. So first file, what is the name, what is the length, from byte number 1 to byte number 100. So second file, length. Third file, name, length. Fourth file, name and length. Fifth file, name and length. So everything, it is stored in index file, and the entire part 0 file is containing all the files that are packed. Further, all these details are hidden from application, however, which uses HAR URI. So if you use HAR URI like this, so it will display everything. So normally when you display like this, you'll get myfile.har. So if you say myfile.har ls, it will just display part 0. In part 0, part file, actually you have all those contents. So if you want to see what is there in all those contents, if you just give lsr har colon, you give the file name. So if you specify, it will display in detail. So these are all the files. File number 1, file number 2, file number 3. These are the files that are stored. So this is how archive can help to manage your name node memory efficiently. And to delete the archive, you say rm. Rm, you just give rm. R means the recursive, deletion of the file. RMR, recursive deletion of the file. So that can be considered. There are limitations of this archive. The first one is there are few limitations for this. So creating an archive creates a copy of the original file. So we need as much as the disk space as the file you need to archive to create the archive. Yes, it is the same. And there are currently no support for archive compression, although the files that go into the archive can be compressed, of course. So compression with respect to block level is there, but further compression you don't have. And archives are immutable. Once they are they have been created, to add or remove the file, you must recreate the archive. So immutable. Immutable means you know very well. Once it is written, once it is kept, you cannot alter it. So if you want to alter it, you have to delete everything. You have to recreate the thing. So similarly, as noted earlier, HAR files can be used as input to MapReduce. However, there is no archive-aware input format that can pack multiple files into a single file, single map split. So the processing a lot of small files, even HAR can be still inefficient. So that's why there's a reason, we say don't use Hadoop, ecosystem for small files on small files. Further, finally, if we are hitting name node memory limits, even after taking steps to minimize the number of small files to files into the system, then consider using Hadoop federation to scale the namespace. So it is actually Hadoop federation will certainly create another set of problem. So these are all the some of the limitations that we have with respect to HAR, and we have advantages also. Right. So that's all for today's class. Thank you for attending today's class, and The class video is available in this website, and also study material. Module 4 is available. Module 5 is another small chapter. So kindly attend, bear with me for another a week or so. We will finish the entire online classes, somehow syllabus, and later you can certainly start reading, preparing well for your examination. Meanwhile, if you get any doubts, so you're always welcome to approach me. Thank you. Have a wonderful weekend.